Okay, okay. No issue. This week, please complete the increasing and decreasing as well as maxima and minima, which we will do today. Okay. So yesterday we were discussing the maxima and minima. So we have done a graph. Okay. And then we have done this. Okay. Okay. Um, Next our topic is extreme value of a function in its domain. Okay. So what is mean by extreme value of a function in its domain? Suppose we have a function fx. Suppose we have a function this fx, which is defined on this interval. Okay. So that means this function exists only for this interval AB. Then fx is said to have the extreme value in AB if there exists a point C such that fc is either maximum or a minimum value of f in A. Okay. So let me draw a graph, and from the graph we will try to understand this concept. Suppose we have this function like this. This exists only for interval AB. So we have this function, we have this AB. So this function exists only for AB. This is fx. Okay. This is your x, this y. Now, fx is a real valued function defined on this interval. Fx is said to have the extreme value in this interval. We are saying that fx have an extreme value in this interval if there exists a point in this interval C such that fc is either a maximum or a minimum value in this interval. Okay. So if suppose we have a point C here, so we can see at this point, this function have the maximum value. This function have the maximum value, which is given by fc. So this is the topic that if fx is a real valued function, fx is said to have the extreme value in this interval if there exists a point C such that fc is either have a maximum or a minimum value of f in AB. Okay, so here we are saying that fx have the extreme value. Why? Because there exists a point C such that fc is the maximum value of the function. Now the same thing is true when we have a minimum value in a function. For example, we have this function. We have this one. Okay, this function exists for A. This is A, and this is B. Okay, this is X, this is Y, and this is fx. So we have a point C here. Okay, as you can see, this fc is the minimum value of the function. So we will say that this function has the extreme value. So if we have a maximum or a minimum value of a function in a particular interval, then we will say that the function have the extreme value. Okay, next point is the number fc in this case is called the extreme value of the function in AB, and the point C is called the extreme point. So this fc is called the extreme value. This is extreme value. And the C is extreme point. Extreme point. This fc, this is again extreme value. Extreme value. And this C is extreme point. Extreme point. Okay. I hope everyone understood this. So please note down this complete. Then let me know. I will change the slide and you will draw the graph for this one. And if anyone have a doubt, then please let me know. All of you, please raise your hands once it is done. Darshan, you are again 15 minutes late today. Please be on time, Darshan. Okay. We need to complete the syllabus as soon as possible. So please join at the correct time, otherwise you must miss some topics. Please note down this, Darshan. I will again explain this to you. Everyone, please raise your hands if it is done. Okay, Nabil, good. Atif, Darshan, Huzefa. Okay, Darshan, good. Atif and Huzefa, please let me know if it is okay, Atif. So who is left? Huzefa. Okay, great, Huzefa. Please note on this graph. Okay, so Darshan, I will again explain this to you. In the previous slide, you have checked the extreme value. So what is the extreme value? Suppose we have this function. This is fx, and this is a point C. Okay, and this is fc. So in this function, if in a function you have a point C such that at this point the function have a maximum value or a minimum value. Okay, so if in a function there exists a point C such that the function have the maximum or a minimum value at that point, then we will say that this function has the extreme value. Okay, so this value fc, this is called the extreme value, and this point C, this is called the extreme point. Similarly, if we will check this graph, then at this point the function has the minimum value. Okay, and so that's why this point is called the extreme point, and again this point is called the extreme, this value is called the extreme value. So when we will say that a function have extreme value, when there exists a point C such that at that point the function have a maximum or a minimum value. Is it clear, Dushan? Dushan, is it clear? Okay, great. So please note down this, Dushan. Okay, and then again raise your hands. We will start a new topic. Okay, Nabil, good. Atif, Darshan, and Husefa, please raise your hands if it is done. Okay, Atif, good. Darshan, Husefa, Nabil Khan, please raise your hands if it is done. Nabil, you have just you have joined right now.
So me, sir?
No, Nabil Khan.
Yes, sir.
Okay, Nabil, please be on time. Okay, you are almost 20 minutes late.
Today?
Yes.
No, sir, I was on time.
Okay,
I
okay,
joined at 4. Yeah.
okay. Sorry. Okay. Okay, so I hope everyone has done this. Okay, so we are going to start the next topic. If anyone is left, please let me know. Okay. I hope everyone has done this. If anyone have a doubt in this topic, then please tell me. I'm going to erase this. Okay. So the next is find the maximum and minimum values if any of the following functions. So we need to find the maximum and minimum values of this function. Okay. So first we will do later on. We will check the second one. Okay. This also we will do later on. This also, yeah, fourth one. Okay. We need to we need to find the maximum or minimum value of this function, mod x plus 2. So can we say this mod x plus 2 is greater than equal to 0? Is this correct? Please raise your hands if it is correct. Can we say that mod x plus 2 is greater than equal to 0? Nabil, okay. Atif, Darshan, Zephyr, Nabil Khan. Is it correct if we will say that mod x plus 2 is greater than equal to 0?
Yes.
Okay. Darshan, is it true or false?
It's true, sir.
It's true. Good, Nabil. Darshan and Huzefa, is it true or false? Okay. Huzefa, is it true or false? True. Very good. Okay, because this is modulus, you know that model, whatever the value you will put inside this mod, it will convert that into a positive value. So mod x plus 2 will be greater than equal to 0 because the minimum value can be 0. Otherwise, it will be greater than. Now, as per the question, we have a minus here. So what we will do? Subtract 1 from both sides. Subtract 1 from both sides. Both sides. Okay. So what you will get here? X plus 2 minus 1 greater than equal to minus 1. Now this is your actual question. So what we are saying that fx is greater than equal to minus 1. So anyone can, okay, so we get this in equation fx is greater than equal to minus 1. Now for this function, anyone can tell me the minimum value. Minimum value of this function?
-1.
Minus 1. Okay, Nabil. Atif, Darshan, Huzefa, Nabil Khan. Can you tell me the minimum value of this function?
-1.
Minus 1. Okay. Darshan, Huzefa, Nabil Khan. Here we are saying fx is greater than minus 1. Okay. Darshan, Huzefa. Minimum value of this function? Good, Darshan. Very good. Okay. So here we are saying that this is greater than equal to minus 1. So that means minimum value of fx is minus 1. Is minus 1. Okay. And we will get this minus 1 at what value of x? Anyone can tell me? For what value of x we will get a minus 1? Check here. We have this one. Fx is equal to fx is equal to mod x plus 2 minus 1. Okay, fx is equal to mod x plus 2 minus 1. So, Zafar, you are partially correct. Okay, so fx is equal to mod x plus 2 minus 1. When we will get a minus 1, when this will be 0. When this will be 0. So this modulus is very good, Zafar. Now it is correct. So this is 0 for what value of x?
Sir,
Mod
minus
x
2.
minus 2. Okay, so when you will put x is equal to minus 2 here, you will get minus 2 plus 2 and minus 1, which will give you 0 minus 1. So that means you will get the minimum value, minimum value of fx is minus 1 at x is equal to minus 2. Okay. Now, if you will check the maximum value, then this function do not have any maximum value. Because from this, we get to know that this is greater than equal to minus 1. So it will be greater than equal to minus 1. But what is the maximum value? That is, it is not possible to calculate that. For example, like this function. Okay, this is keep on increasing. So we don't have any maximum value in this case. This is just an example. So we have only a minimum value for this one. Okay, so just give me a minute. Okay, then please all of you note down this and let me know. Then we will start the next question.
Sir, so maximum value is at infinity.
Yes. So we will say that there is no maximum value. It is keep on increasing. Okay. Okay, Atif, very good. All of you, please raise your hands if it is done. Okay, Huzaifa, okay, Nabil. So Darshan and Nabil Khan, please confirm if it is done. Darshan and Nabil, is it done? So, Darshan and Nabil Khan, is it done? Shall we start next? Darshan and Nabil Khan, is it done? Shall we start next? Okay, Nabil. Darshan, is it done? Darshan, my voice is audible. Oh, okay, great. So we will try next one. Okay, this one. Please try this question and share your answer.
The maximum value of f of x is 3, sir.
Maximum value is 3. Very good. This is correct. Very. Anyone else got this answer? Atif, Darshan, Huzefa, Nabil Khan. No? Anyone have a doubt? Atif, Darshan, Huzefa? Do I need to solve it? Atif, Darshan, Huzefa, Nabil Khan, do I need to solve this question?
So it's a maximum value 3.
Yeah, that's correct. Maximum value is 3. Darshan, Huzefa, Nabil Khan. Shall I solve
Yes,
this?
sir, same answer.
Same answer. Good. Huzefa and Darshan. Okay, great. Minimum value, this function do not have any minimum value. Okay, so please check here how we will solve this question. X plus 1 is, we know that this is greater than equal to 0. But in the question, negative is given. So we will multiply this, multiply 1 by minus 1. Okay, so what will happen? We will multiply minus x plus 1. So the sign of inequality will change. You know that if in an inequality, we will multiply it by negative or divide by negative, then sign of inequality will change. Now what we will do in the question, we have plus 3. So we will add plus 3 here. So minus x plus 1 plus 3 less than equal to 3. So this is actually what? This is a function. So fx is less than equal to 3. So the maximum value of the function is 3. And this function do not have any minimum value. Okay. And maximum value, we will get the maximum value at which point? At x is equal to? Anyone? We will get the maximum value at what point? At x is equal to? At x is equal to?
Minus 1.
Minus 1. Very good. Okay. When this will be 0, then we will get a 3. When this will become 0? At minus 1. Okay. So I hope this is clear to everyone. I'm going to erase this. Now we will check the next question. Okay. Sine 2x plus 5. Yes, this is a very, very good question. So all of you, please try this one. Sine 2x plus 5. Or I will solve this question. Okay. In this type of questions, we will first of all, in this type of question, we will try to solve the question directly. Okay. So anyone can tell me, first of all, try to change the trigonometric ratio as per your question. So anyone can tell me what is the maximum and minimum value of sine? What is the maximum and minimum value of the sine? Anyone can tell me what is the maximum or minimum value?
The maximum is 1.
1.
Minimum
Very good.
is 0.
No. This is correct. Maximum is 1. Anyone else? What is the minimum value of the function?
Minus 1.
Minus 1. Very good. I hope everyone remember the graph of the sinusoidal function. This one. Okay. This is 1. And this is minus 1. Okay. One more thing. You also remember that for theta is equal to 90. Sine is, or we can say sine 90 is equal to 1. And sine 270 is equal to minus 1. Okay. So we get this sine 2x. This is greater than equal to minus 1 and less than equal to 1. Okay. Now in the question, we have a plus 5. So add 5 in this. This is 1. Add 5 in 1. In 1. So what we will get? Minus 1 plus 5 less than equal to sine 2x plus 5 less than equal to 1 plus 5. Okay. Here we will get 4 less than equal to sine 2x plus 5 less than equal to 6, 1. Okay. So we have this value. We will change this as per the question. So in the question, we have a plus 5. So we will add 5. We will get this. Okay. Now, if you will see then anyone can tell me what is the minimum value of this function?
4.
4. Very good. And the maximum values?
6.
6. Very good. So it is fx and less than equal to 6. So if you will see, this is the minimum value. Okay. And this is the maximum value. Okay. So is this clear? Darshan, Huzefa, Nabil Khan, this question is clear?
Yes, sir.
Okay. Nabil, good. Okay. Darshan, good. Huzefa, this clear? Great. So please note down this. Okay. Then raise your hands. We will start the next question.
Sir, we should not find the value of x.
No, there's no need to find the value of x. Okay.
Sir.
Okay. If you wish, then you can write like this, sine 2x. Okay. So when you will get 4, when this will be equal to -1. So you need to find the angle for which you will get the -1. Okay. And for 6, you will equate this with 1. Okay. And from this, you can find out the value of x for which you will get a 1. Okay.
Yes.
So for you, Nabil, I'm going to show this. Sine 2x, this is equal to sine pi by 2. So 2x is equal to pi by 2. So x is equal to pi by 4. Okay. And for this one, sine 2x is equal to sine 3 pi. Okay. So x is equal to what? 3 pi by 4. So in the question, they have not mentioned that we need to find point also. So we can just write the maximum minimum value. So all of you, please raise your hands once it is done so that we can start the next question. Okay, Nabil, very good. Atif, Darshan, Huzefa, Nabil Khan, please confirm. Okay, Atif. Okay, Nabil, good. Darshan and Huzefa, is it done? Okay. 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 So Darshan, please raise your hands once it is done. Darshan, shall we start next? Okay, great. Okay, next, please try this question. Okay. Anyone get the answer? Please let me know. Anyone got this answer? Question number 7. Please check here. Answer is 7. Okay. We have mod sin x 4 plus 3. So we will do the same thing. First of all, we will check for sin 4x. Anyone can tell me what is the maximum and minimum value of this function?
0, 1 and -1, sir.
Very, very good. Okay. So I hope this is clear to everyone that the minimum value of this function is -1 and the maximum is 1. As per the question, we also need plus 3. So what we will do, -1 plus 3 less than equal to sin 4x. We will add plus 3 less than equal to, we will add plus 3. So here what we will get, 2 is less than equal to sin 4x plus 3 less than equal to 4. Now, if you will see the question, we have a modulus here. So what we will do, we will find out the modulus. So here we will get sin 4x plus 3. Okay. Here also we will find the modulus, here also. As both sides are positive, so there will be no change in the inequality. So if we have a 2 less than equal to sin 4x plus 3 less than equal to 4. So again, the minimum value is 2 and maximum value is 4. Okay. So please note down this, raise your hands once it is done. And if anyone have a doubt, then please tell. Everyone, please raise your hands if it is done so that we can start the next question. Is it done? Nabil, Atif, Darshan, Huzefa, Nabil Khan. Okay, Nabil. Atif, Darshan, Huzefa, Nabil Khan. Is it done?
Yes, sir.
Okay. Darshan and Huzefa. Darshan and Huzefa. Is it done? Shall we start next? Okay. Darshan. Okay, Darshan. I got your message. Now, 2 questions are left. Please check this first question. First. Okay, so this is fx is equal to 2x minus 1 whole square plus 3. We have this function. So first of all, we will analyze this 2x minus 1 whole square. So anyone can tell me this one, 2x minus 1 whole square.
Always greater than equal to 0, sir.
Very, very good, very good. So I hope this is clear to everyone because this is a square, so this can't be negative. That's why this is greater than 0. But this can be 0. Therefore, we will write greater than equal to 0. Now, as per the question, we have a plus 3 here. So add 3 in first, add 3 in first, add 3 in first. So what you will get? You will get 2x minus 1 whole square plus 3 greater than equal to 3. So what is this? This is our actual function. Fx is greater than or equal to 3. So anyone can tell me the minimum value?
3, sir.
Minimum value. I hope this is clear to everyone. This is greater than or equal to 3. That's why the minimum value is 3. Okay. And at which point we will get this 3? When we will get 3 for what value of x?
1 by 2, sir. Minus
1 by 2. That's correct. Okay. When we will get a 3, when this will be 0. When this will be 0, equate this to 0. So you will get a 1 by 2. So at x is equal to 1, x is equal to 1 by 2, we will get the minimum value. We will get the minimum value. Okay. So I hope this is clear to everyone. So please note down this, raise your hands once it is done so that we can start the next question. Okay. Or you can try these 2 questions in the homework. Okay. These 2 you can do in the homework. If you have any doubt, then we can discuss, but I hope you can complete this. Okay. Then we will start the next topic. So please raise your hands once it is done. Everyone, please please note down this question. Okay. And then note down the second and third. You need to try this in the homework. And then we will start the next topic. Please raise your hands once it is done.
How will do the second one?
Okay, second. Okay, I will explain this to you right now. Please raise your hands once it is done. Okay, Nabil. Okay, Nabil Khan. Atif, Darshan, Huzefa. Is it done?
Yes.
Okay, great. Darshan and Huzefa, is it done? Okay, Huzefa. Darshan, is it done?
So second one, it is like f of x is greater than or equal to 12x plus 2.
Okay, I will explain to you, Nabil, just right now. Darshan, I hope this is done. Okay, we are going to start next question. Is it done, Darshan? Okay, great. Please check here for this second question. Okay, you have fx is equal to 9x squared plus 12x plus 2 plus 2. Okay, so in such type of questions, we will form a perfect square. In class 10th, you might have a topic of making a perfect square. So how we will do? First of all, make this x square unity. Okay, so always take common. Whatever the number you have here, take common. So you will get x square plus 12x by 9 plus 2 by 9. Okay, this is equal to now 9. Okay, this is x square. Cancel this, you will get a 4x by 3 plus 2 by 9. Now, whatever the coefficient of x you have, for example, in this case, you have 4 by 3, always divide that with 2. So you will get 4 by 6. Okay. Whatever the coefficient of x you have, divide that with 2. Here you will get 4 by 6. Do the square of this one. You will get a 16 by 36. Okay. So add this 16 by 36. Subtract this 16 by 36. Okay. Now this one, and this number which you have added, this always make a perfect square. So this is 9. Here you have here you have 9. Here you have this one, x square plus 4x by 3 plus 36 by 16 by 36. Okay. So this term, coefficient of x, and what the number you have added, write this in the bracket. Next is plus 2 by 9 minus 16 by 36. This always make a formula. So this is what? Check the formula. This is a square b square plus 2ab. So we can write it like this. A square plus b square, we can write x square plus 4x by 3 plus 4 by 6 whole square. And here you can take the LCM. LCM is 36. So 4 to 8 minus 16. Here you will get 9. And here you will get what? A plus b whole square. X plus 2 by 3 whole square. Okay. And here 8 minus 16, you will get a 8 by 36. Open the bracket. So you will get 9 x plus 2 by 3 whole square. Okay. Minus 9 into 8 by 36. So here you will get what? 9 into x plus 2 by 3 whole square minus, cancel out this, 9, 1, 4 and 2. So here you will get minus 2. Okay, this is your fx. So if you have a quadratic equation, try to make a perfect square. Okay, now check this one. X plus 2 by 3 whole square is greater than or equal to 0. Next we need 9 here. Let this be 1. Multiply 1 by 9. 1 by 9. So what you will get? 9 into x plus 2 by 3 whole square greater than or equal to 0. What you need? Minus 2. So write x plus 2 by 3 whole square minus 2. So greater than or equal to minus 2. Okay. So anyone can tell me what is the maximum or minimum value of this function? Anyone can tell me what is the maximum or minimum value of this function?
So minimum value is minus 2.
Very good. Minimum is minus 2. Minimum value is minus 2. Okay. And this minimum at x is equal to minus 2 by 3. I hope this is not clear to everyone. So I will again explain this question. Here we have a quadratic equation. After this, we have somewhat simple questions. Okay. We have this function fx is equal to 9x squared plus 2x plus 2. What we will do, we have to make a perfect square. Okay. So how can we make a perfect square? This you have done in class 10. This concept you have done in class 10. So you need to make this x square unity. So take 9 common. Whatever the coefficient x you have, here you have a 4 by 3. Divide that with 2 square. And whatever the number you are getting, add and subtract it. Okay. Then this one, and what the number you are adding, this always make a perfect square. So write this like this. Remaining constant you need to write here. Now this one, make this formula. Okay. And what is the constant you have, you will get here. Open the bracket. we will get this calculation. Now we can analyze this in the same way as we have done the previous questions. Okay. So all of you, please note down this and let me know if you have a doubt in this question. And this concept, making of perfect square, we need this concept in integration also. Okay. So we will again try to understand this concept in integration. Only this making the perfect square. Okay. So please note down this, raise your hands, then we will start a next topic.
Sir, for x cube plus 1, how will you do, sir?
X cube plus 1, we can solve this by a different method. Okay, this is a direct method which we are doing without any formula. We are analyzing the function without any formula. Okay, so we have different formulas to find the maximum and minimum. So we can do that later on also, or I will try to explain this directly to you. Okay, x cube plus 1. So all of you, please note down this and raise your hand. Then we will check this. Fx is equal to x cube plus 1. Okay. Okay, Nabil, good. Atif, Josefa, Nabil Khan, is it done?
1 minute.
Okay, okay. Please let me know once I need to change the slide.
Done.
Okay, Atif. Josefa and Nabil, is it done? Josefa and Nabil Khan, is it done? Okay, Nabil, okay, Josefa. Then you need to note down this also. So please complete it. And again, raise your hands. Okay, Nabil. Atif, Josefa, Nabil Khan, is it done?
Done.
Okay, okay. Josefa, is it done? Okay, great. Now the last is x cube plus 1. Okay, so fx is equal to x cube plus 1. This is third question. If you will analyze this function, okay, if x is greater than 0, then x cube plus 1 is greater than 0. Okay, if you will put the value of x which is positive greater than 0, then this complete x cube plus 1 is also greater than 0. If x is less than 0, then x cube plus 1 is less than 0. Okay, so if x is greater than 0, this function is greater than 0. X is less than 0, this is less than 0. So x cube plus 1 do not have any maximum or minimum value. Maximum or minimum value. Okay, so this function do not have any maximum or minimum value. So we will discuss the same function, the cubic, later on also by using a different method. We have different methods to find the maximum and minimum value. So we will use those methods to again analyze this function. Okay. So if this is done, then please raise your hands. And if anyone have a doubt, please let me know. Okay. And please remind me this cubic function when we will discuss the methods to find the maximum and minimum value. Okay. I will again explain this to you. When we will do the first derivative test, I will again explain to you that why this function do not have any maximum or minimum value. Okay. So Nabil just done good. Atif, Huzaifa, and Nabil Khan, please raise your hands once it is done. Good, Nabil, Atif, and Huzaifa, is it done? Atif, is it done? Shall we start next? Huzaifa, is it done?
Yes, sir.
Okay, okay. Huzaifa, is it done? Okay, great, Huzaifa. Got your message. Okay, now we have a next topic. So till last topic, we have discussed that what is a maximum and minimum value of a function. Okay, till last topic, we have discussed that what is a maximum and minimum value of a function. Now here we will discuss local maxima and local minima. Okay, this is a very, very important topic. In exam, you will get a question from this. Okay, please try to understand this properly. So this complete theory I will tell you later on. Okay. Okay. Suppose we have this function fx. This is a function fx. This is point A. And this is point B. Please understand this carefully. This is a very, very important topic. You will get a question in exam from this topic. This is your fx. Okay. If we will check this point, let this point be C1. Okay. If we will check this point, then at this point, if we will check the value of the function, that you can see that this value is greater than the neighboring point. We have chosen this point C1. And here, if we will check, then at this point, the function have the value which is greater than the neighboring point. You can check the neighboring point like this. Okay, these are the neighboring points. And at this point, the function have the value greater than this. Similarly, if you will analyze this point, let this point be C3. So at this point, the function have the value greater than the neighboring point. From these, the function have the value greater than the neighboring point. Similarly, at this one. The function have the value greater than the neighboring point. If you will analyze the neighboring point, then at this point, the function have the value greater than the neighboring point. Okay. So these points are called the point of local maxima. Local maxima. Okay. So what is the local maximum value of the function? These are the local maxima, and this is the I will write here local maximum value of the function. Local maximum value of the function Okay. So what is exactly local maxima And what is local maximum value of the function? Local maximum is not the greatest value of the function. Local maxima is not the greatest value of the function. Local maxima is what? The value at the value is greater than the neighboring point. This doesn't mean that that at this point the function have the maximum value. At this point, the function have the value which is greater than the neighboring point. Okay. If you will check, for example, if we will check this point, then this point have the value greater than this local maxima. So local maxima doesn't mean that the function have the maximum value. Local maxima means the function have the value which is greater than the neighboring points. Is this clear? Okay, just give me one more thing. One more point we will discuss. After that, I will ask the question from you. Now, suppose if we will check this point, this is C2. Okay. At this point, the function have the value which is lesser than the neighboring points. At this point, the function have the value which is less than the neighboring point. You can see here, these are the neighboring points. These are the neighboring value of the function. At this point, the value is less than the neighboring points. Similarly, if we will check this, this is C4. This is C4. So at this point, the function have the value which is less than the neighboring points. Check here. Okay. Similarly, this one, C5. So here the function have the value which is less than the neighboring points. So these points are called what? Point of local minima. Point of local minima. Okay. These are called point of local minima. So local minima doesn't mean that the function has the minimum value at that point. This means that the function has the value which is less than the neighboring point. You can see here, this is the point of local maxima. There is a local maximum value of the function, and this is the local minimum value of the function. Local minimum value is greater than the local maximum value. So local maximum value doesn't mean the greatest value. This means the value which is greater than the neighboring points. Local minimum doesn't mean the value that the function has the minimum value. This means that the value is less than the neighboring points. Okay. Is it clear? Nabil, Atif, Darshan, Huzaifa, and Nabil Khan. This is a very, very important topic. Okay. Local maxima and minimum. Okay. Good, Nabil. Atif, this clear?
Yes.
Atif, this is clear?
Yes, sir.
Okay, today I will not take your test, okay, because I need to complete some topics. I will take your test next week. Okay, okay, Atif, good. Darshan, Huzaifa, Nabil Khan, is this clear? Okay, Huzaifa. Darshan and Nabil Khan, is it clear? Darshan, I have seen you have dropped in between. There was network issue, Darshan? Darshan, you have some network issue? Okay. So we have just discussed the local maximum and minimum. Okay. So what I was telling that at this point, the function have the value which is greater than the neighboring points. Similarly, at this point, the function have the value which is smaller than the neighboring points. So local maxima doesn't mean the maximum value. This means the function have the value which is greater than the neighboring points. So Darshan, is this clear? This is clear, Darshan? Okay, great. So who can again explain this to me? Nabil Khan, can you please explain this to me? What is a local maxima and minimum? Local maxima and local minimum. Nabil Khan. Nabil Khan, will you please unmute yourself? Nabil, this is a very, very important topic, okay? If you have any doubt in
Yes,
this.
sir. Hello.
Okay, yes, Nabil. Will you please explain this?
Local maxima
Yep.
is the point
Where?
where it's less
Yep.
value
Yeah,
of the function.
yeah, local, if we are talking about point of local minima, then point of local minima is a point at which the function have the value which is lesser than the neighboring value. Okay.
Okay.
Okay. So I hope this.
Near point that is always less than the value.
If you are talking about local minima, then you can see this one. This is the point of local minima, this one, and this is local minimum value of the function. So at this point, the function of the value which is lesser than the neighboring points. These are the neighboring points. Okay, this is not your neighboring point. These are the neighboring point. Okay, so we can see here the value is lesser than the neighboring point. Similarly here, the value is greater than the neighboring point. So this is local maxima and minima. Okay, and these are also called the turning points because the graph is taking turn here. If you will see, then graph is taking turn here. So these are also called the turning points. Okay. So local maxima and local minima always occur at the turning points. You will get the point of local maxima and local minima at the turning point only. Okay. And I will draw this graph like this right now. So like this. Okay. I will write B here. The graph is like this. And at this one, I have drawn a corner. This is a corner point. Like this. So yesterday we have discussed the, okay, leave that. This we will discuss later on. So I hope this is clear to everyone. Now we will check the definitions. Okay. Local maxima and local minima definition. Let f be a real valued function and let C be an interior point in the domain of f. I hope this is clear to everyone. Okay. We have a domain of f. For example, in this graph, the domain is from A to B. And these all points are in the interior of domain. Okay. So C is called a point of local maxima. C is called the point of local maxima if there is an h greater than 0 such that fc is greater than fx for all x in c minus h and c plus h. What is meant by c minus h, c plus h? This is your point, suppose C2. So what we have done, we have taken a h which is very, very small, tends to 0. So if we are subtracting minus h from the C2, if we are finding C2 minus h, then you will get the neighboring points on the left side. If you will find C2 plus h, then you will get the neighboring points which are on the right side. Okay, so this definition means only that these are your neighboring points. So the value is greater than fx and the value of fc is called the local maximum value of f. Okay, C is called a point of local maxima if fc is greater than fx for all x in c minus h, c plus h. So this represent only your neighboring points. Okay. Second point is C is called the point of local minima if there is an h greater than 0 such that fc is less than fx. These are your neighboring point. The value of this fc is called the local minimum value of f. So I hope you understood the graph. From the graph, you understood that what is the concept of local maxima and minima. Okay. So please note down this definition. Okay, and draw and let me know, then I will change the slide and note down this graph. If anyone have a doubt in this graph, then please let me know. Okay, they will not ask you about this complete definition. You must understood this graph only. This is enough for you. Okay, so please note down this, raise your hand, then I will turn the slide. Everyone, please raise your hand once it is done.
Done, sir.
Okay, good Atif. Nabil, Huzaifa, Nabil Khan, please confirm if it is done. Okay. Okay, Nabil. Huzaifa, is it done? Huzaifa, is it done? Okay, great. So please note down this graph and again raise your hands once it is done. Everyone, please raise your hands once it is done. Okay, Nabil, good. Atif, Huzaifa, and Nabil Khan, please confirm me once it is done. Okay, Nabil, very good. Atif and Huzaifa, is it done?
Done, sir.
Okay, great. Huzaifa, is it done? Okay, great. So you understood that what is local maxima and minima. I'm again explaining this to you that local maxima minima doesn't mean the maximum and minimum value of the function. This means the value is greater than the neighboring points, and local minima, the value is lesser than the neighboring points. Okay. Now, critical points we have already done yesterday. Okay. We will again discuss this. A point C in the domain of a function at which other derivative is 0 or fx not differentiable. It's called the critical point of f. Okay. What is a critical point? It is a point at which the derivative of the function is 0 or the function is not differentiable. Now we will check the previous graph. Okay. Here. Okay. Please check here. At this point, if we will differentiate this function, okay, we have already discussed in increasing and decreasing that f dash x represent what? This represents the slope of the tangent. So at this point, if you will draw a tangent, so tangent will be like this. So anyone can tell me that at this point, what is f dash c3? Anyone can tell me what is f dash c3? No? Please check here. This is point C3. Okay, this is a graph. Here the tangent is parallel to x-axis. So if a line is parallel to x-axis, what is its slope? Slope is Nabil, I'm sorry, I do not hear
Zero.
you. 0. Okay. So if you are drawing a tangent and the tangent is parallel to x-axis, so the derivative will be 0. So f dash C3 will be 0. We will check this one. Here, if you will draw this tangent, then f dash C4 will be equal to 0. Similarly, at this point, f dash C2 will be 0. Okay. At this point, f dash C1 is equal to 0. C1 is equal to 0. Okay. At this point, f dash C5 is equal to 0. Okay. So what are all these points? These are the critical points. These points where the graph is taking turn. These points of local maxima or minima, these are what? These are the critical points. Why? Because at these points, the derivative is 0. Why it is 0? Because the tangent is parallel to x-axis. So its slope will be 0. So always remember these points, the point of local maxima and local minima. These points are what? These points are the point of, these points are what? These points are the critical points. So if you will find the derivative at these points, then you will get a 0. Anyone can tell me this is a corner point. This is a corner point. So, okay, I will write like this. This, please change your graph. This is B. Okay, I've extended this graph and let this be C6. Please do this change in the graph. This is C6. So anyone can tell me f dash C6 is what? The function is differentiable at this point or not?
No, sir.
No. Why?
It's not point of local maxima or minima.
No, this is a point of local maxima, but the function is why the function is not differentiable. Anyone can tell me? We have discussed this concept in differentiability.
There's no tangent
It's
to
a
the
corner
point.
point.
Yes, that's perfect. Perfect, Atif. Very good, Nabil. So this point is a corner point. So we already know that the function is not differentiable at the corner point. Okay, so f dash C6 does not exist. Or we can say, just give me a minute. We can say that fx is not differentiable, is not differentiable at x is equal to C6. Why it is not differentiable? Because it is a corner point. So we know that at the corner point, the function is not differentiable. But this is also the critical point. Why? Check the definition of critical point. What is a critical point? At which either the derivative is 0 or function is not differentiable. Okay, what is a critical point? The point at which the function is 0. Sorry, f dash x is 0 or the function is not differentiable. So if we will check this graph, then at all these points, the derivative is 0. But at this point, the function is not differentiable. That's why this is also a critical point. And this is a point of local maxima. So local maxima and minima you will get at the critical. Okay, at the critical point, you will get the local maxima and minima. What's the critical point? The point at which the derivative is 0 or the function is not differentiable. I hope this is clear to everyone now. If you wish, you can mark in your graph the same thing which I have mentioned here. That f dash C1 is 0, this is 0, this is 0, function is not differentiable. Okay, I will give you just 1 minute for this. So please complete this, mark in your graph. then we will check the definition of the critical points. Please raise your hands once it is done. Okay, we just have half an hour. So we need to start one formula. Okay, very good, Nabil. This is correct. Sorry, Nabil. Okay. Atif, Huzaifa, and Nabil Khan, please raise your hands if it is done. Atif, Huzaifa, and Nabil, please raise your hands if it is done. Okay, Nabil, very good. Atif and Huzaifa, is it done?
Yes, sir.
Okay, great. Huzaifa, is it done? Okay, great. Okay, so I hope now you understood that what is a critical point. So the point at which the derivative is zero or the function is not differentiable is called a critical point. So this point of local maxima and local minima we will get at the critical points. Okay. Okay, so please note down this critical points. Raise your hands. We will then check the next theorem. Please raise your hands once it is done. Okay, Nabil, good. Atif, Huzaifa, Nabil Khan, please raise your hands if it is done. Okay, Atif, Huzaifa and Nabil. Okay, Nabil, good. Huzaifa, is it done? Huzaifa, is it done? Okay, great. Now, we'll check the next point. Next theorem is let f be a function defined on an open interval I. Suppose C belongs to this interval. If f has a local maxima or local minima at x is equal to C, then either f dash C is 0 or f is not differentiable. Okay, so what is mean by this theorem? What I already told you. If you will check this graph, then the local maxima and the local minima we get at the critical point. Okay, from the graph, you can see that local maxima or the local minima you will get at the critical point. What is the critical point? Where either the derivative is 0 or the function is not differentiable. Okay, the point at which the function is not differentiable or 0. So the same thing is written here that local maxima, just focus on this line, local maxima or local minima at x is equal to C exists, then either you will get a derivative 0 or the function is not differentiable. Okay, so that means local maxima and local minima occur at the critical points. That means where the function is either non-differentiable or the derivative of the function is 0. So I hope this is also clear to you. Okay, just remember this, local maxima and minima exist at the critical point. And what is the critical point? Where the derivative is 0 or not differentiable. So all of you, please raise your hands once it is done. Then we will check the next point. Is it done? Nabil Ahmed, Atif, Huzefa, Nabil Khan. Is it done? Shall we check the next point? Everyone, please raise your hands if this is done. Okay, Atif, good. Nabil, Huzefa, Nabil Khan. Is it done?
Yes, sir, done.
Okay, good, Huzefa. Okay. So I hope everyone has done this. Now, check the next point. Next is the converse of above theorem needs not to be true. That is a point C at which f dash C is 0 or this is not differentiable. Need not be a point of local maxima or minima. Okay. So what we have discussed so far that the local maxima or minima exists at the critical point. Okay. From the graph, if we will check, then the local maxima and minima exist at the critical point. So these all points are the critical points. But the converse is not true. That means if you have a critical point, then it is not necessary. Then at that point, you always have a local maxima minima. For example, we will check this graph. Like this. Okay. At this point, if you will draw a tangent, that will be parallel to x-axis. Okay. At this point, the tangent will be parallel to x-axis, and you will get a 0 here. I will tell you what this is. Fx is equal to, if you will take this one, x cube. So if you will find, don't get confused, leave this. So if from this graph, if you will see, okay, this is a function fx. Let this point be O. So if you will find f dash O, that will give you 0. So this is a critical point. That's fine. This is a critical point. Why? Because if you will draw a tangent, that will be parallel to x-axis and the derivative will give you a 0. But is this a point of local maxima? Check here. Check here. If you will compare with the right side, then at this point, the value is less than the neighboring point. But if you will compare with the left side, then at this point, the value is greater than the neighboring point. So this point is not a point of local maxima. This point is not a point of local minima. This point is called the point of inflection. Point of inflection. What is a point of inflection? Where the point at which the function is neither local maxima nor local minima. So this point is called point of inflection. Here we can see that this is a critical point, but this is not a point of local maxima or minima. So that means there exists some critical points where you do not get local maxima or minima. So such type of points are called the point of inflection. So what is the remark? That the above theorem is the converse of above theorem is not true. There exists some point where you will get, okay, I'm sorry, this is equal to 0, where the f dash c is equal to 0 or f is not differentiable. Okay, but so what I mean to say that there exists some critical point where there is no local maxima or minima. So such type of points are called the point of inflection, where you do not have local maxima or minima. Okay, this point of inflection we will again discuss later on. Is this clear? Nabil, Atif, Huzaifa, and Nabil Khan. This remark is clear. Okay, Nabil, good. Atif, Huzaifa, and Nabil Khan, this clear?
Yes, sir.
Okay, Huzaifa and Nabil, raise your hands. Okay, good,
Yes, sir.
Huzaifa. Okay, great. Okay, so that cubic function, x cube plus 1, we will discuss later on. That actually that function is, in that function, there's a point of inflection. Okay, we will discuss that later on. So please note down this. Again, raise your hand so that we can start a topic. Everyone, please raise your hands. Please draw this graph also and raise your hands once it is done. Okay, Nabil, very good. Atif, Huzefa, Nabil Khan, please raise your hands if it is done. Okay, Huzefa. Atif and Nabil is okay. Nabil Khan, is it done?
Yes, sir.
Nabil? Okay, great. Okay, now we will check the next point. Okay, so let me erase this. Now, we have drawn the graph. Point of inflection. What is the point of inflection? The point at which fx is neither local maxima or minima. Okay, the point at which there is no local maxima or minima. So such type of points are called the point of inflection. Okay, so please note down this point. What is the point of inflection? The point at which fx is neither local maxima or minima. From the graph we already understood, we will again discuss this point of inflection later on. Okay, so I hope you all have completed this. I'm going to change the slide. Please note down the last point also, point of inflection, the point at which fx is neither local maxima or minima. Okay. Now we have a two derivative test. Okay. In the earlier question, we have checked the maximum and minimum value directly. For this one, to find the local maximum minima, we have two methods, you can say, first derivative test and second derivative test. So right now I don't have so much time. So we will discuss the second derivative test first, because majority of questions will be based on second derivative test. Okay. When we will use the first derivative test is quite lengthy. So when we will use the first derivative test, when the second derivative test will fail. When the second will fail, then we will come back to the first derivative. Okay. This we will discuss next week, because I need to start some questions, because we have I've already prepared the assignments on the basis of this. Leave this. Yep. Yes. Second derivative test. Okay. We will first discuss second derivative. Then next week we will check the first derivative. Again, the same thing. Let fx be a function, define an interval I and c belongs to I. Okay. There is a point c which belongs to your interval I. Let f be twice differentiable at c. This is already given that f, the function is twice differentiable, is differentiable 2 times. Okay. Now, check the first point. X is equal to c is a point of local maxima. X is equal to c is a point of local maxima if f dash c is equal to 0. We have a point c. We will say that this is a point of local maxima if f dash c is equal to 0. Why this is 0? Because there is a critical point. And if you will differentiate it again, if you will differentiate the function again, and you will put the point, then this will be less than 0. Okay. So what is the process of finding local maxima? Differentiate the function, find c, differentiate again. If you will get a less than 0, then the value of fc is the local maximum value. Okay. So there's no need to solve the question directly as we have done earlier. We have a proper method to solve these types of questions. Okay. The second is x is equal to c is a point of local minima if f dash c is equal to 0. And if you will differentiate 2 times, then that will be greater than 0. In this case, fc is local minimum value of f. The test fail if f dash c is 0. And if you find the second order derivative and it is also 0, then your test will fail. So what we will do, then we will again go back to the first derivative test. Okay. So what is the first derivative test? We will discuss later on, because maximum questions, majority of questions we have to do by using the second order derivative test. Second order derivative test is more simple than the first one. That's why we are using this derivative. Otherwise, you're free to use any test, but the second is quite easy as compared to the first one. Okay, so I hope this is clear to all of you. Please note down this, raise your hand. We will solve a question, then this rule will be clear to you. This theorem will be clear to you once we will start solving the question. So please note down this, raise your hands. Everyone, please raise your hands once it is done. Is it done? Nabil, Atif, Huzaifa, and Nabil Khan?
1 minute, sir.
Okay. Okay, Nabil, good.
Done, sir.
Okay, Atif, very good. Huzaifa and Nabil Khan, is it done? Okay, Huzaifa, good. Nabil Khan, is it done?
Yes, sir.
Okay, great. Okay, so you have noted down this. We will take a question and try to understand the second order derivative test. Okay. Find the local maximum and local minimum values of the function f given by this one. So please check here. We have this fx is equal to 3x to the power 4 plus 4x cube. This is a very, very simple method. Okay. 12x squared plus 12. So what you need to do, first you need to find the critical points. So how we find the critical points? We have already done increasing and decreasing. Differentiate this. F dash x. So this you will get what? 12x cube, 12x square minus 24x. Okay. Then put f dash x is equal to 0. So what you will get here? 12x cube plus 12x square minus 24x, okay, is equal to 0. Then find the critical points. So factorize it. What you can do, take common. 12x you can take out common. What you will get here? X square plus x minus 2. Minus 2 is equal to 0. Here you will get 12x and factorize this x square. Okay, and plus x minus 2. So just give me a minute. So we can write like this: plus 2x minus 2 is equal to 0. So here we will get what? 12x, and here take out common x plus 2. Take out common here minus 1. You will get x plus 2 is equal to 0. So from this you will get what? 12x. Here write x minus 1, x plus 2 is equal to 0. Okay. Now equate all these variables to 0. What you will get? So first we will get 12x is equal to 0. So this will give us x is equal to 0. Then x minus 1 is equal to 0. This will give us x is equal to 1. Then x plus 2 is equal to 0. And from this you will get x is equal to minus 2. So these are the critical points. 0, 1, and minus 2 is the critical point. So this step we have already done in increasing, decreasing. So I hope no one has an issue in this. So please raise your hand if this is clear to you. Up to this one. Nabil, Atif, Huzaifa. Okay, Nabil. Atif, Huzaifa, Nabil Khan. Atif, Huzaifa, Nabil Khan. Is it clear?
Yes.
Yes, sir.
Okay, great. Huzaifa? Huzaifa, is it clear? Okay, great. Okay, so we have find out the critical points, same method which we have done increasing, decreasing. Now what we need to do? Now we again need to differentiate this. First time we have differentiated. Now we will again differentiate it. So what was our function? f dash x is 12x cubed. So this will become 36x square. Okay, 36x square. Then 24x, then minus 24. Okay, so we have again differentiated it. Now f double dash. Now put all these critical points. So first is 0, put 0. What you will get? 0 plus 0 minus 24. So f double dash 0 is less than 0. Okay, so in the question, what they're saying, find the local maxima and local minima of the function. Okay, so f double dash is less than 0. So x is equal to 0 is a point of what? Local maxima or minima? Is a point of local minima. Again, please check your rule.
Local maxima.
Local maxima. Atif, Huzefa, Nabil Khan, is it clear? Atif, okay. Huzefa, Nabil Khan, is it clear? X is okay. X is Nabil Khan, clear?
Yes, sir.
Okay, so x is equal to 0 is the point of local maxima. Okay, if you will check the rule, then what was there in the rule? Yeah, this is 0, and if f double dash c is less than 0, the value fc is the local maximum value. So x is equal to 0 is a point of local maxima, and what is the local maximum value? And local maximum value is what is the local maximum value? What was your function? 3x to the power 4 plus 4x cube minus 12x square plus 12. Okay, so put 0 here. So f0, you will get 0 plus 0 minus 0 plus 12. Okay, so f0 is equal to what? 12. So 12 and local maximum value is given by this one. Just give me a minute. So we'll remove this. X is equal to 0 is a point of local maxima and local maximum value at x is equal to 0 is what? 12. Okay, is 12. So what we have done here, we have find out the critical points, then we have put the point in the function and find out the local maximum value at x is equal to 0. Okay, I hope this is clear to everyone. Now we have what the other critical point we have? X is equal to 1. Okay, next we will find f double dash 1. So this is what? So what was our function? This one, put the point 36 into 1 square plus 24 into 1 minus 24. So here we will get 36. Okay. So what is this? So x is equal to 1. F double dash 1 is greater than 0. So x is equal to 1 is a point of local minima. Is a point of local minima. Okay. Now we need to find the local minimum value. So what we will do, we will put 1 here. This is our function. So this will be 3 into 1 to the power 4 plus 4 into 1 cube minus 12 into 1 square plus 12. So this is equal to what? 12 will cancel out. Here you have a 7. Okay. So I will remove this. Okay. I need some space. So local minimum value at x is equal to 1 is 7. Next, last we need to check x is equal to 2. So right here f double dash 2, which is equal to what? 36x squared. So 36 okay. So 36x squared, 36 into 2 square plus 24 into 2 minus 24. So what you will get here? 36 into 4 plus 48 minus 24. Okay. So this will give you what? 144 plus 24. So 168. Okay. So f double dash 2 is greater than 0. So x is equal to 2 is a point of local minima. Okay, now we will calculate this value. F2 is what? 3x to the power 4. So 3 into 2 raised to the power 4 plus 4x cube, 4 into 2 cube minus 12x squared minus 2 squared plus 12. This is equal to 648, 32, 48 plus 12. So 48 cancel out, you will get here 44. So local minimum value at x is equal to 2 is 40. Okay, so I hope this is clear to everyone how we need to find the local maxima and local minima. This is clear, Nabil, Atif, Huzefa, Nabil Khan. Nabil, okay,
Yes,
Nabil.
sir.
Okay, Nabil Khan. Atif, Huzefa. Okay, Huzefa. Atif, this clear?
Yes.
So this is a very, very important topic. You will get a question in exam from this. Okay, and this is a very simple rule. So I'm going to change the slide. Please note down this, confirm me, then we will end the class. Okay. And next week we will continue this. Your homework is assignment 3rd. Okay.
Sir, here we got x is equal to -2, right, sir? So in
Oh.
the ending, why we put only f of 2?
I'm sorry. I just missed this. This is -2. Sorry. So I will write -2 here. -2, -2. Okay. So we will get what here? So here we will get a -48, -24. So here we will get what? -72. Here we will get a 72. So the same thing, local minima and local minimum is this. At x is equal to, okay, the same. Here we will write -2, -2, -2. So this will give us 3 into 16. Here -4 into 8. Here -12 into 4 plus 12. So 48 minus 32 minus 48 plus 12. Okay, so again 48 will cancel out. 32 plus 12 will give us -20. So x is equal to -2 is -20. Okay. Thank you, Nabil, for highlighting this. Now, everyone, please note down this. Raise your hands once it is done. Then we will end our class. Your homework is assignment 3. So this week, please complete first assignment 2, then complete assignment. Try to solve the question of assignment 3 because there are word problems which we have not discussed yet. Other than the word problem, try to do as much as questions you can. It is possible for you in assignment 3. Okay. Okay, Nabil, very good. And Atif, Huzefa, Nabil Khan, is it done? Please let me know once I need to change the slide. Okay. And I will take your test next week. Okay, Nabil Khan. Huzaifa and Atif, is it done? Shall I change the slide? Done, sir. Okay. Okay, so I'm going to change the slide. If anyone miss anything, please let me know. Everyone, please let me know if it is done.
Done.
Okay, Atif. Huzaifa and Nabil, I'm going to start the next slide. This is done. Okay, Huzaifa. Nabil Khan, is it done? Shall I move to next slide? Nabil Khan, shall I move to next slide now?
1 minute.
Okay, okay. Take your time.
Done, sir.
Okay, Nabil. Atif, Huzefa, shall I move to next?
Yes, sir.
Okay. Huzefa, shall I move to next? Okay. Please let me know if this is done.
Done, sir.
Okay,
Done,
Nabil,
sir.
very good. Okay, Atif, very good. Huzefa, is it done? Okay, then Nabil and Atif, if you wish, you can drop. Okay, we will continue this next week, and please complete assignment 2 and try to complete the question from assignment 3 also.